Hello, welcome to the Domat webinar. Today we will go through a training on Domat IDE for advanced users. Below the video you will find the timestamps of the individual sections. You can jump straight to the passage you are interested. On our channel you will also find short videos that deal with specific instructions, for example setting up proxy or secondary network. Further information can be found in a FAQ section on our website or in the Domat IDE program help. Now the help is also available on our website. First, I will show you how to work with the data from another PLC. We will do it using a data source. So here I have an example of a project which is called the data source project. In the main program I have some data points here. So now I will create a new project. I can attach PLC, for example, mark mx.3. Here I can see the channel RxIO input-output module. So I would add to the system the data source. Here I need to allocate the folder with that project. So we have it here, data source project. Here I would put IP address of the PLC, or I can use a proxy connection. And now we can add channel. Protocol would be SSCP, and I would add device. And here I would select data source. So address would be 1 and username, usually default one is admin, and password is RW. Double click, and here I would add a reading group and some data points. So select the group, and here we can choose the source variable. So we can see that the program is offering me the data points from that remote PLC. So like this, I can map it to this IO, and now I can use it in this PLC in the program and so on. Similarly, we can use it even for HT300 or Domat Visual mobile application. I would just add a terminal. And here we have the channels. So we can assign PLC and also the data source. So the terminal will show us the information from both sources. If you want to have more PLCs in one project, we need to switch to full mode. So I will just delete this, and we can switch to full mode. Okay. And now we can add another controller. We can put here, for example, again, marks.mx3. Usually, if you have like large building, you can have PLC for each floor, so you can name them accordingly. For example, like this. So I will name analog input in the first PLC, for example, outside temp. And now if I want to use it in the second PLC, I need to add channel. Channel is SSCP, add device, select the first floor PLC, device address 1, admin rw is default password and username. And here I would add group for reading and data point. I need to build a solution first. So now I can select the outside temperature here. And because I have the full mode now, the default is that the autogen is not selected for every data point. So I need to turn it on manually like this. And now I can use this in our second PLC. When I create a new program, because I'm in full mode, it wouldn't be automatically assigned to the PLC because the program doesn't know if I wanna run the program in the first PLC or the second one. So when I create new program, I need to add the program to the PLC. So double click, add task, and add the program. So now it's up to me if I want to run the program in the first one, second one, or both of them. Everything is customizable. So I can put all the programs in one folder, or if I want to more separation, I can create a separate folder in this executable project. You can read about this more in depth on our webpage and in the article linked below. Here you can see a few options how to do it. When you have 2 or more PLCs, you will see that you can start debugging for each of them separately. And when you are looking at the program running there, you have to select which PLC do you want to look at right here. Now let's look at how to work with program libraries. Now I have this program in basic mode, so I can only add new library project. So we will switch to full mode like this. And now I can add existing library project. I prepared one before. It's this one. So as you can see, I have a new library project here, and I have a custom block and custom program. So I will go back to my last project. And now I can add library project. Library project here, new library project. So as you can see, now I have the custom blocks and custom programs here. If I want to use it in my program, I have to put it here into references like this, and now I can use it in main, for example. So I will double click main, fupla blocks, and I can put here the function block, and also in the PLC I can map the program from the library, as you can see here. Advantage of the libraries are that you can have different versions of the custom blocks or programs. As you can see here, this was the first version, 0.0, and when I notice some problem or something, I can create new version, and I can set the previous version status to be broken. So in the program I will see warning that this block has broken status and should be not used, and I can easily right click and replace version. So as you can see, this is version 0.1, and when I click OK, it will update to the latest version, and I don't have to connect inputs and outputs manually, so it's easier. If you map the library project remotely and then you want to send this project to someone and you would only send this folder, he would see that the library project is missing. So either I have to remember that and I can send him the folder with the library also with the program, or I can copy the folder inside this project folder and map it not remotely but from this local folder. So for example, as you can see, I have the library project here, so I would copy this whole folder and then put it inside this folder, and then I would delete this one and add existing one, but from my own folder, just like this. Of course, in a company, typically those libraries will be stored on the server and anyone maps them from that server to be sure that there are always the latest current versions of those programs. And now I will delete this one and this one. If I want to add my library into the default ones, like these, I would need to copy the SLB file to the program files Domat IDE library right here. And now I can put it here, new library project. And here I can see the custom blocks. So every new program in this version of the Domat IDE can use my new library project from now on. If I want to create a new library, I would right click here, add new library project, and it will create subdirectory in my project directory. And here I can add references, I can add function blocks, programs, everything I want. As you can see, again, this is version 0, and I can create new version 01, and I can build a solution. And now I can set status to, for example, broken. So like I said, a user will be noticed that he should upgrade to newer version of the function block or newer version of the program. Now let's look at the tasks. I have to be in the main profile, otherwise it will be grayed out and I won't be able to edit. I double click on the PLC and you will see tab tasks. Here I can add the programs to the main task, and the task can be different types. We have a freewheeling, that means the program runs in cycles and it's not affected by the time in any way. Cyclic, here I can set a period, for example, every 500 milliseconds it will be triggered. Of course, it also depends on how long the cycle lasts. And the last type is an event. So it will be only triggered when there is a, for example, rising edge on some variable. There can be an infinite number of these event tasks, but there can be only one freewheeling or cyclic type. So I can have one freewheeling and I can have, for example, 10 event tasks at the same time. Now let's see how to do it when I need to switch a sensor from one input into the another. For example, I have mapped Wago here and I have a card 451, which is analog inputs. And here I have the temperature sensor on analog input 1. And for example, there was some problem, so AI1 is not working anymore. So I want to move it to, for example, AI8. And if I have it already used in the program, I don't want to change it in the program, I can do it using disable autogen feature. So if I have a program in the full state, I can right click on the card 451 and set autogen, reset autogen, including attributes, click OK. It will turn off autogen on all my inputs. Autogen false. Now I can delete it here, OK, and put it here, click OK. And now I can set autogen, including attributes, click OK. And now I successfully switched the temp to AI 8, and I don't have to change anything in the program. As you can see, the Vago PLC has different cards for different inputs and outputs, and sometimes I need to move the card because typically, for example, I want to add a communication card 652, and when I add it, it's at the end, but this communication card, I want to put it in the front because of the delay of the bus. So if I would detect all the cards again and then import them, it would change the naming structure because the position of the card is actually in the name. As you can see here, the name is 04, which is position 4. So if I would import them again, that would change the name, and that way I would have to change it, all the inputs and outputs in the program. So if I don't want to do that, I can simply just change the position on the bus. So I will leave the position 1 here, and here I will change it to number 2, 3, 4, and 5. Because I didn't import them, I didn't change the name 04, so it doesn't affect the name for the autogen. As you can see here, 04 is still the same, but physically 651 card is in the first position on the bus. Now let's look at the profiles. We have them here. Typically it's used when I want to connect on site or remotely, for example, using proxy. The profiles will affect these settings on this right column, and you can see some squares here, for example, red, green, and red with the white square inside. Here in the help, you have description what that means, if it's inherited from the main profile or not. And I can simply double click on one profile and it will change the connection parameters to TCP and local address. And when I click on the proxy profile, it will change the connection parameters to the proxy, and I can add proxy ID here and connect remotely. Just be careful if you are changing something, use the main profile again. So double click on the main profile, and now I would change something. Because sometimes it can happen that I am inside one of the sub profiles. I would change something, and then I will change the profile to a different one, and it's back. It's changed back because I didn't do it on the main profile. So just be careful. So the next chapter is Domat proxy. You can use it to connect to the PLC remotely, even if you don't have a public IP address. We have an article on our website describing the function here. As you can see, the PLC connects to the proxy server, and you connect to the proxy server, and there is a secure connection. We offer the proxy IDs for free. Just send us an email to support@domat.cz. For example, please send us 3 proxy IDs and we will generate them for you. Each PLC must have unique proxy ID. We have another article with procedure how to set up the proxy connection. Basically, you upload the proxy ID to the PLC and start debugging. Then you will see the status of the proxy connection. If it's idle, it's already successfully connected and waiting for other clients. So you can connect using Domat IDE or Domat Visual from touch panel or Domat Visual from your mobile device. In this way, you can view information from many remote PLCs. So for example, one mobile application or one touch terminal can show, for example, 3 different PLCs, and each of them is connecting using the proxy ID, so they can be on separate places. Now we will explore alarm blocks, how to work with them and how to send SMS and emails. So if I have a program, for example, main here, I have a choice of 2 alarm blocks. We have a BD56 single alarm block and BD57 alarm memory. This one is for multiple alarms, so it can be used as a global alarm. So for example, I have an input here. It signals me water leak, and when this turns true, it will be memorized in the alarm block, and later I can see when the alarm occurred and who confirmed it or reset it. If I want to send SMS or email, I would connect to the output send mail trigger or send SMS trigger. For this to work, you need to set up the alarm channels. So when I double click on a PLC, we can see messaging tab, and here I can add alarm channel. So I have already prepared 2 channels. One is SMTP for sending emails, and second one is GSM for sending SMS. So the emails, you can fill your SMTP server username and password. For example, in our country, it can work with Centrum CZ and Seznam CZ, but it's not working with the Gmail or Outlook. So you need to try which provider is working for you. Alarm channel for SMS, you basically set up the GSM modem on the serial port. Usually it's connected using 232 connection, and here you can add pin code and AT commands for initializing the GSM router. We have some of them prepared here, so you just need to click and click apply, and it will add these AT commands here for you. Just be careful, especially with the BGS type. They are set up from the factory to expect control signals over a serial connection, but our PLCs are set up to have the control signals disabled. So if it's possible, you can set up the flow control on serial port settings, but for Vago, it's not possible because they have different pinout for the connector. So you need to disable the flow control in here and also change the configuration of GSM modem to not expect the flow control. We have an article about this in our FAQ, and just using the AT commands, you can set the GSM modem in a way that he's not expecting the flow control. So in the program, it would look like this. I have some sensor, and it's connected to the alarm server, and output is connected to the send mail trigger and send SMS trigger. Here I would fill in the channel, which is the mail, which I have right here. And for the SMS trigger, I would put there channel SMS, which is here. And of course, you can add a message, recipient, and when there is a rising edge on the send, it will send the SMS or the email. On a graphic template, you would add alarm icon. We have it here, graphical gadgets. Here is the alarm for the global alarm, and alarm point is for one single alarm. The default looks like this, but of course you can change it in a states mapping. You can put there different pictures. These are just the default ones. You can download the alarm log from the PLC using Domat IDE, PLC operation, and download alarm log. You can also do it from the terminal, so I can show preview of the terminal. I have to log in as an admin, so capital A, admin, and password is admin with small a in the beginning. This is the default password. So now I'm logged as admin, so I have the alarm log option here. And it will download it from the PLC. And also I can log in on the web server. And when I'm not visitor, when I am admin, again, small a, capital A, I have more options here. So here I would see the alarm log and I can download it as a CSV file. Now we will show how to set up the Bacnet server channel. So PLC, I will add new channel, but not the regular channel, but the server channel. I can name it and select protocol and add server device. We will fill device port 47808. Local port will be filled by the system itself. Device instance, for example, 1. You should fill some management password because it's possible to restart PLC without the password. So I can double click on device. So I can add variable, for example, some temperature, and we can deploy the solution, upload it to the PLC. Now I can start Yabe program, which is a Bacnet client. The PLC is running. And here we can add the device. And we can see the device PLC on our IP. And here we can see the temperature reading. So it's working. Now we can try Modbus server. So I will add channel for the server again. This one's gonna be Modbus. And we can use TCP. Add server device, right click, and double click on the device. The address will be of the PLC, port 502, and device address 1. When I double click on the device, you can see that we can map analog and digital values here. It's coils and registers. So I can add variable, for example, temperature again, and in coils, I can add some digital values like this. Okay, I will deploy the solution. Now we can start Modcom tool. We can connect to the server. TCP gate, connecting. We can switch to address view and fill in the address 1, register 1, length 1. And we can see it's communicating because it's green and we have value of 1256. When I disconnect the PLC, you can see it's red, so it's not communicating. Now I will show you how to work with the pop-up template. I can show you the preview. The logic is that you have, for example, 4 heaters and each of them has its own settings, and you need big buttons because the operator is using gloves, so you couldn't fit all the control to one screen. So we can create a small pop-up window with the controls. So when I click on heater 1, a small window will show up and I can adjust it. Heater 2, heater 3, heater 4. So it's like a sub page. For this you need to have the project in full mode. So when you create a template, it will offer you not just the PLC or terminal, but also function block and program. So as you can see, this template is for FB, function block. So when I click on it, you can see that you can adjust it. And here on the main template, I have a pop-up gadget like this. So this is pop-up and it's connected to the pop-up heater, this one, and variable is in the main program. So as you can see, we have 4 instances of function block heater. It's empty, it's just for the show, but we have it in the main program, and then in the main template, each of the pop-up button is connected to the different function block instance. Similar is the template gadget. When you create new template, you can adjust the size and background and whatever. And on the main template, you would add gadget template like this and select this template and also connect it to the function block. So again, in the main program, I have 4 instances of function block room. Inside I would have the logic to adjust the rooms. And on the main template, I have 4 instances of the template. And it's connected to the function block room. And when I adjust the template, for example, move this button here, it will affect all of the templates at the same time. So I can save some time with editing similar sub templates. So next chapter is certificate management. You can upload certificates from the certification authority to the PLC and then use them to secure the connection between PLCs and other servers. You just right click on the PLC, PLC operation, and manage certificates. Here you would see all the installed certificates. Right now we don't have any installed. And also you can download a certificate straight from your server and download it locally or upload it directly to the controller. We have an article which explains this more in depth. It's on our website, TLS Security, and we have the first chapter. It's more general description. What is it and what does it do? And in the next chapter, here are the examples of the communications and more details. You can find links to all these articles in the video description below. Another topic I would like to mention in this training is programming in ST code. You need your project to have in full mode. Then when you are creating new function blocks or program, you can select the ST structured text. This topic is perfectly shown in our article on our website called Programming in ST in 4 chapters. You will find examples of function blocks, functions, and programs. Like I said, the links will be in video descriptions. or you can search for them in the search bar, or you can use FAQ, and we have it in category designing and programming of control systems. So the last chapter, I will show you how to export and import prototypes of Modbus and MBus hardware devices. So firstly, I would create a channel for Modbus, and I would add device. Here I would fill in all the information, for example, manufacturer and model. Double click on it and add group for reading. And add data point, assign the group, name it according to the Modbus table from the manufacturer. And when I'm done with this, I can export the device. So I can either export item, which will create a CSV file in my project folder, or I can create library device. As you can see, build succeeded. The prototype was saved to the folder disk C, program data, Domat, IDE version, hardware library, Modbus, and this is my generic 1.1 device. This file I can send to my colleague. If I want to add it to the library, I would open program files folder, Domat version hardware library, and here I have the libraries, so I would add new folder, Modbus, and paste the file here. Now I will have it in my library. So when I click add library device, I can see my AC unit. It's similar with MBus devices, and also I can export the whole channel of devices. Export item, it will create the channel CSV file, or I can export like this, and it will create the channel.hv file. So I can import the whole channel at the once. Here, right click on PLC, export, import, and I can import the whole channel. Now I have it twice here. So it is working like this. That's all from today's training. If you have any questions, don't hesitate to contact technical support via WhatsApp, phone, or email. Thanks for your attention and see you next time.